In last class we have been discussing with respect to got a generation of a Dsbsc, and you got some methods. What are the advantages of you got a Dsbsc over the respective got a double sideband with the carrier. And here basically what is you got in double sideband suppressed carrier. What you are doing this one, the respective got a carrier component is going to get to be suppressed. How it is going to get to be suppressed? When the Dsbsc modulated signal crosses the 0, that is nothing but it has got crosses the 0. The modulated signal crosses the 0 here. And also we have been discussing with respect to got a spectrum of this one. And here if you see here, what is that you got, the respective sideband that are going to get to be centered with the carrier frequency. And also we have been discussing with respect to got a generation of you got a ring modulator. That is nothing but in the respective got a generation of a ring modulator, we have been using it as a 4 diodes that are connected in the same direction. That is nothing but in the same direction, in the sense that while conducting they form it as a ring in which all they point in the same direction. All they are forming it as a same direction, that are going to get to be controlled by got a square of a carrier signal. And during the positive half cycle of the carrier signal, 2 diodes are going to get to be conducted. During negative half cycle, 2 diodes are going to get to be conducted. And here the respective the square okay, its Fourier series is going to be given by the respective Fourier series. That is nothing but due to the switching action of a diode, that is diode act like a switch. Due to the switching action of a diode, basically what I got, the respective Dsbsc signals are going to get to be generated. And here next one we have been discussing with respect to detection. That is nothing but we should have to recover the message signal. We have to recover the message signal m of t from the Dsbsc signal. And here what you are doing this one, in this one first we have been multiplying the modulated signal, and then we have been applying a locally generated carrier signal, and then it is passing to got a low pass filter. And here whatever the carrier signal we have been generating from the local oscillator, it should be the same as that of C of t, which one is applying to the respective product modulator. That is nothing but S of t is nothing but C of t into M of t. And here the carrier is same as that of the carrier frequency is same as that of a frequency which is generating from the respective local oscillator. And also what you got, when we are passing to the respective low pass filter, we have been recovering the respective M of t, this one. That is nothing but baseband signal. And here because of some harmonic component in the first term, what you got, because of harmonic component in the first term, that is nothing but actually it is AC dash divided by 2. That is nothing but first term what you got, it contains what you got 2fc, this one. And second term what it is a scaled version of a message signal. Because why it is scaled version of a message signal? Because if you see here, this one, here we are multiplying this one, and here S of t is nothing but C of t into M of t, and here AC into AC dash. Due to this one there is a scaled version of a message signal. For this one, whatever the cutoff frequency we have been choosing for the low pass filter, it should be greater than the message bandwidth. Certainly it should be greater than the message bandwidth, because it is scale version of the message signal. And it should be not greater than, it should not be greater than what you got, it should not be greater than you got 2fc minus w. It should be less than 2fc minus w. That is nothing but central frequency, that is nothing but the carrier frequency is symmetric to about on the both sides. That is nothing but 2fc minus w, this one. And here if you see here the spectrum of this one, here if you see the spectrum of this one with respect to that one. And next one, here we have in the second type of a demodulation, that is nothing but you got a cost receiver system. And here in the cost receivers, basically what you are doing this one, if you observe this one is a synchronous system suitable for, it is what you got. Here also we have been recovering the M of t. It consisting of a two coherent detector. That is nothing but, if you observe here from the diagram, is a coherent detector. This is a coherent detector, and here it consisting of you got a two coherent detector. And next one what you got here, we have been applying these two coherent detector, we have been applying with the same message input signal. That is nothing but same message input signal is nothing but Dsbsc signal we have been applying to the these two, this one. And here next one, and here one individual, what is it? We have been using it as a local oscillator. That is nothing but the voltage control oscillator acts like a local oscillator. It acts like a local oscillator, and whatever the local oscillator signal it is generating, that is nothing but one is a in phase, another one you got a quadra phase with respect to each other. That is nothing but in phase and you got a quadra phase. In phase and you got a quadra phase refers to you got a with a phase difference of 90. With phase difference of you got a 90. If it is cos, it becomes you got a sin. For that reason, we have been using it as a in phase and you got a quadra phase this one. And here whatever the frequency of the local oscillator, we have been applying to this one, these two. It means that it should be same. It should be same as that of a carrier frequency which have been applying to the input of the product modulator. And here the detector in the upper path we are called as a in phase, detector in the lower path we are called as a quadra phase, this one. And here whatever these detector will going to get to be coupled, it going to form it as a negative feedback system. So such a way that why it should be got a negative feedback, it means that in order to maintain the carrier wave, the carrier wave is synchronized with respect to a local oscillator. That is nothing but whatever the carrier frequency we have been applying to the product modulator, it will be same as that of a local oscillator, It means that you need to maintain the local oscillator frequency should be same as that of a carrier frequency applied at the product modulators. Next one, and here one thing is that very important, and here what you got next one, here the local oscillator is of a same phase. What you got? The local oscillator is what you got a same phase as that of you got a carrier wave. It means that when you got your C of t is same as that of a frequency which is generating from the local oscillator, it means that here the desired m of t is going to get available. And what about this one below channel? The Q channel output will be 0, because when you are getting it as when the carrier frequency and you got a local oscillator frequency are synchronized, it means that phase will be 0, and for that reason what you got? The quadrature null effect in the sense that is going to get to be available from this phase discriminator. That is nothing but it will differentiate the respective phase. That is one with respect to I channel, one with respect to Q channel. When the frequency are going to get to be synchronized, it means that when the C of t is same as that of whatever the frequency generated by the local oscillator will be same. It means that the I channel will produce desired m of t, whereas Q will go to get to produce quadrature null effect. That is the phase error is 0. And next one is that suppose that local oscillator, suppose if anything you got phase difference, that is nothing but if any you got a phase drift, that is nothing but if you got any phase difference, it means that I channel will be not going to get to be remain unchanged. Why it will not going to remain unchanged? Because in the respective carrier frequency and you got a local oscillator frequency are synchronized, so that they are not going to unchanged. What about this one? The same signal at the Q channel, whatever the same signal is appearing at the Q channel, it means that proportional to you got a pi. That is nothing but it means that if any change in the phase, if any change in the phase of a Q channel means that it only affected it in the Q channel. It is totally got a independent of a I channel. And next one is that the Q channel output will be the same polarity of same polarity as a I channel output. And why it have got a same polarity of I channel output? Because they are going to it in the one direction of a local oscillator. That is nothing but the Q channel. This is got a Q channel, this is got a I channel. Q channel got a I channel will be got a same polarity as in a for one direction of a phase drift, one direction of a phase drift. And for other direction what is it got? There will be got a change in the polarity because of 90 phase shift for other direction. That is nothing but during positive cycle of this one, what it got? They have got a same polarity. During negative this one, what it got? There will be got a phase shift. For other direction there will be got a phase shift because you are showing it as a 90 phase shift. Here you are showing it as a 90 phase shift. That is nothing but sine becomes you got a sine theta plus 90. It becomes you got a cos. That is nothing but here the same thing we are taking this one, and here next one, and here and next one. What you are doing that whatever the output you are getting this one from the I channel and you got a Q channel, you have been combining in the phase detector, and whatever you have been combining with respect to got a phase difference, it is generating you got a constant DC signal. That is nothing but a constant DC signal that controls what you got? The respective got a local phase error in the voltage control oscillator. That controls what you got? That controls, that is whatever DC control signal is obtained, that automatically corrects. That is nothing but control in the sense that automatically corrects the voltage control oscillator, voltage control oscillator.